Good evening, everyone. Now, today we shall be having our class, and the subject we shall be treating is chemistry. So, we are starting first with chemistry, and the topic we shall be treating is element, compound, and mixture. But we shall be taking elements first today. Now, when we talk of elements are substances which cannot be broken down into a simpler substance. Elements are substances that cannot be split into a simpler substance. That is, you cannot break them further. That's elements. Now, we have millions of elements known, or we have thousands of elements. We have hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium. To stop it at the first 20 elements. Now, these elements, they are classified into 3 parts. But for now, we'll talk of the 2 parts of its classification. We have elements based on their reactivity. That is what we call the radioactive element and the non-radioactive element. Talking of radioactive elements are elements that undergo a spontaneous decay. While a non-radioactive element are those elements that do not undergo a spontaneous decay. Now, based on their property, what we call the metal, non-metal, and metalloid. When we talk of metals are elements that ionize by losing electron. They lose electron. Metals lose their electron. That is their valency electron. And don't forget, the number of electron loss is also referred to as their valency. So if an element is losing 1 electron, its valency is 1. If an element is losing 2 electrons, its valency is 2. In chemistry, when an element is losing electron, it is denoted with a positive sign. The positive sign means cation. Take for instance, sodium. We have it to be Na plus. That Na plus, the plus them that is losing 1 electron. Magnesium, Mg2 plus, means that it's losing 2 electrons, and its valency automatically is 2. But because it is carrying 2 plus, the 2 plus referred to its oxidation number. That's for magnesium. Sodium has Na plus. The plus means the oxidation number of sodium is 1. Now, how do we get it to know that they are losing 1 electron or they are losing 2 electrons? That is where we have to talk of their electronic configuration. That is the KLMN shell, which you have to fill the shell with the atomic number. And noting that the first orbital can only take maximum of 2 electrons, while the other orbital can take maximum of 8. Now, in the case of sodium now, which is having 11 atomic number or proton number, you fill this orbital like this: 2, 8, 1, 2, 8, 1. That is, the first orbital will be having 2 electrons, the second one will be having 8 electrons, making 10, and the last one will be having 1, making it to be 11. The 1 electron is having there is going to lose it. That makes it to be Na plus. Now, classification of metals. Metals are classified into 3. We have the very active metal, we have the moderate active metal, and the non-active metals. The active metals, they are when we say an element is active, very active, That is, its power is much. It can displace a weak element. It can displace a weak element. When we say to displace means to drive away. For example, you have a powerful person and a less powerful one. The powerful man can drive away the lesser one. So it also happens in chemistry, where we have the highly reactive metals have the ability to displace the weaker one. Take for instance, in a reaction where we have zinc, or let me say we have sodium reacting with hydrochloric, because sodium and hydrogen, they are both positively charged. But in that reaction, because sodium is more active than hydrogen, so sodium will displace hydrogen, taking hydrogen away and snatching the chlorine. So we now have sodium chloride, a common salt or a table salt. Then we have hydrogen as a gas that will be liberated. Then we have the moderately reactive one. This one are not overreactive. They are not too powerful and they are not less. They are average, meaning that they are balanced. They are moderately, their reaction is moderate. Take for example, we have zinc, we have magnesium, and so on and so forth. While the non-reactive metals, these kind of metals cannot undergo a reaction. Now, properties of metals. Metals, as they are sonorous, that is, they make sound. They are conductor, that is, they allow the passage of electricity. They are luster, that is, they shine. So metals are hard, but generally, let me say metals are hard. Then we move to their chemical properties of metals. Metals will react with a triazocarbonate. When metal reacts with a triazocarbonate, let me say metal will react with an acid. If metal reacts with acid, it will liberate hydrogen gas. But the liberation of hydrogen gas has to do with the reactivity of that metal. A metal will react with halogen compound to form a salt. Metal will react with halogen compound or halogen element. When we say halogen element, we mean the group 7 element. That is, for example, we have fluorine. So when metal like sodium reacts with chlorine, we have sodium chloride, which is salt. When sodium also reacts with fluorine, we have sodium fluoride, and so on and so forth. Now, moving on to that, we take one of the member of group 1 element, which is assumed to be a metal, because the group 1 and group 2, they are metals. So talk of hydrogen. In the next class, we are talking of hydrogen in the next class. So please feel free, if you have any question, you can always forward it, and let's make the class a very active one. God bless you. And please use this medium to always read your book at home. Don't say because you are at home now, it is time for you to be playing. You still need to take your book and read. God bless you. And have any question, once again, please forward your question.